sensible. Let's say the dependable variables we talked about, the memory and then the alcohol.
Okay. Who else would like to try? Genevieve, would you like to try? Sheila, are you there?
Sir, I'm here. Sir.
Yes, will you like to try? The difference between correlation and...
Sir, you said that with the regression analysis, it talks about how two or more variables are related. And with that one, the effect cannot be known. But with the correlation, that one, it depends, the independent variable can be manipulated. And so the effects can be known.
Okay, so thank you for this feedback. And please, all of you, listen attentively, because these are the fundamentals. In fact, these things that I'm explaining, you should have done it in research methods. And my focus would have been just teaching you how you make the HR forecast. But looking at how some of you are struggling, I want to take my time. All right? So please listen again. I'm saying that in both correlational analysis and regressional analysis, you are trying to determine the relationship between two or more variables. So even in ANOVA, we deal with independent variable and dependent variable. In regression, you will be dealing with independent and dependent variable. In correlation, you'll be dealing with independent and dependent variable. However, the main difference between regression and correlation is that regression goes beyond correlation, or it goes beyond the establishment of relationship to determine the strength of the independent variable on the dependent variable. In other words, the effects of the independent variable on the dependent variable. So whereas in a correlational study, we will say that alcohol has a positive or negative relationship with memory, in regressional studies, we will say alcohol has a positive effect or a negative effect on memory. So you realize that in these two statements I've made, in the correlational statement, I said that alcohol has either a positive or negative relationship, just a mere relationship. But in a typical regressional study, we will say that alcohol has a positive or negative effect on memory. So you realize that in these two comparisons I'm making, I am able to confidently say the effects of alcohol in the regressional study, unlike in the correlational study where I just say the two are related, but I don't really know which one is having the impact on the other. Please, is it clear?
Yes, sir. For now, it's clear. Yeah.
Let me give another example. Yeah. Okay. Sefako.
Yes, sir. So, according to the explanation, can we say the regression is dealing with the entirely like between the alcohol and the memory, the regression is so strong that you can read everything out on them, but the correlation can only talk about part of it.
Yes, you are 100% correct. So in terms of the strength of the prediction, regressional analysis has higher power than correlational analysis. Is it clear?
Yes, sir.
Simply put, regressional analysis is used in establishing cause and effects So if you are interested in establishing cause and effect, then you go for regression. But if you are just interested in how two or more variables are related, then you go for correlation. So this implies that in both correlational and regression analysis, you will have independent variables and dependent variables. That was the correction I was trying to make for you people to get. Okay, now let's make progress. I mean, some of your research methods.
So in our research method, we had only only one classes also. So we haven't gone anywhere. Maybe
you've done only one class.
It's like, yeah, one class
really?
that we did. And today that we'll be having a second class for tomorrow. Yeah, tomorrow.
Okay.
So we haven't gotten anywhere closer to what you are telling us.
I see. Then your thesis, how will you be doing it?
Oh, so we'll manage it when we get there.
All right. It is well. Yes.
So, please, can you do us a favor after the class? You send us the audio, the recording.
Yes, I'm actually recording. That is why I've been reminding all of you that please mute your microphones, especially if you are not answering a question or you are not asking a question. Okay. I'm recording it. So we understand when we use regression, right? When we want to establish cause and effect between two or more variables. And these variables, one tends to be what we call independent variable, and the other tends to be called dependent variable. The independent variable is the variable that we manipulate in the experiment or in the study. And the dependent variable is the variable that we observe to ascertain the efficacy of the independent variable on. So in the example I gave, the memory becomes the dependent variable because that is the variable we are observing. And the alcohol becomes the independent variable because that was the variable we manipulated by administering 1 thought, 5 thoughts, and so on and so forth. The same thing can be brought into the field of HR when we want to make forecasting, more specifically, demand forecasting. So we were saying that in demand forecasting, we want to project or estimate the future need for human resources in terms of their quality and quantity. Now, this projection is done based on certain factors that we take into consideration. So the future need of human resources becomes our dependent variable. In other words, the number of people we need to employ becomes our dependent variable. And this number of people we have to employ is contingent on a number of factors, such as perhaps an expansion policy we want to embark on, our organizational objectives, what are some of the factors we raised initially? The environmental outcome of our environmental scan, and so on and so forth. All those factors becomes our independent variable. Please, is it clear up to this point?
Yes, sir.
Good. So in the field of HR, the dependent variable, so for the purpose of the human resource demand forecasting we are doing, the dependent variable is always the need for human resources, or how many people we have to, we will need or we will hire. Then the independent variables is, it could be anything. It could be the particular season we find ourselves in, the technology we are now going to employ, the changes in our corporate objectives, an expansion drive we want to embark on, a new product we are trying to bring, and so on and so forth. Okay. So please, have you gotten the main indicators we use in the regression analysis as far as the HR forecasting is concerned? Now, let me quickly add something. When we say the relationship between two or more variables is positive, when we say the relationship between two or more variables is positive, it means that as one of the variable goes up, the other variable also goes up. So when we say the relationship between alcohol and memory is positive, it means that the more you consume alcohol, then the higher your ability to recall. That will be a positive relationship. Now, when we say the relationship between two variables is negative, it simply means that as one variable goes up, the other variable also decreases. So in the alcohol memory scenario, a negative relationship between alcohol and memory will mean that as one consumes alcohol more, it becomes very difficult for them to recall what they have learned. Again, the closer the correlation coefficient, that is, when you do the computation, the value you get, the closer it is to 1, then the stronger the strength of the relationship. So if you do the analysis and you realize that the correlation coefficient is 0.9, then it means it's very, very, very strong. However, if the correlation coefficient is 0.1, then it means that even though it is positive, it is what? A weak positive. Please, is it clear so far? Hello.
Yes, sir.
Thank you. Now,
Sir, please, no.
Please, who am I? Is it Sheila? Okay,
Sir,
let me
yes.
quickly illustrate.
Sir.
Let me quickly illustrate. Don't worry. Please, can you see my blank screen?
Please, no.
Can you see it now?
Yes.
Good.
Yes.
I am saying that when we say the relationship between two or more variables is positive, when you say the relationship between two or more variables is positive, it simply means that as one variable goes up, then the other one also goes up. So let's say this is the memory. Hey, this is my pen. Just a minute. So this is, let's assume in this diagram, this part is memory and this part is alcohol, right? Now, when we say there is a positive relationship between alcohol and memory, it means that as alcohol increases, memory too will be increasing. So, okay, let me draw the line first. Can you still see the screen?
Yes.
Can you see the screen?
Yes.
Uh-huh. Someone who said, so let me start from down here. 1, 2, 3. Why is the pen misbehaving? One, 2, 3. Now you realize that when the alcohol intake was at 1 tot, the memory of the participant was also what? 1. In the same vein, when the alcohol intake increased to 2 tots, the memory also increased to what? 2. Then when it increased to 3, the memory efficacy also increased to what? 3. This is what we mean by a positive relationship, in the sense that as the dependent variable increases, the independent variable also what? Increases. Please, is it clear?
Somehow, sir.
Hey!
Yes, sir, it's clear now.
Yes,
It's clear now.
yes, the more you drink the alcohol, the more it enhances your memory. So alcohol, cholesterol, memory too is going up. That is positive relationship.
Yes.
Now, when we say there's a negative relationship, it means that rather the alcohol consumption inhibits your ability to recall.
Okay.
So, and on a baby, be say. Now, offer one thought. Then the corresponding ways will be here. Then you take second thought. Then it reduces here. Then you take another thought. Then you are not even able to recall your name. So in that regard, this is how the diagram will be. Pardon my line. I'm just using technology to draw, that's why. But you get the impression I'm trying to create.
Yeah, yes, sir.
So 1, 2, 3. Hey, Penny. 1, 2, 3. Okay, so you realize that when the guy took 1 tot of glass of alcohol, the memory level was somewhere 3. So they were able to recall about 3 issues that they learned. Then they increased the tot to 2. Now, the ability to recall in terms of memory started to decrease. Then they still went ahead and drank 3 tots. Then at this point, they were not even able to recall where they live, their name, and so on and so forth. So you realize that in this particular scenario, alcohol consumption inhibits your ability to recall. So we say there's a negative relationship between the dependent variable and the independent variable. Is it clear? But in this scenario, there is rather a positive relationship. So that is what we mean by a positive and a negative relationship between the independent and dependent variable. In fact, right now, the moment me cry a research method, so I'm not teaching HR. It is well. Now, please, let's apply this quickly to HR. Can you see my screen?
Yes, we can see.
Yes, sir.
But previously, could you see the drawings I was making?
Yes.
Yeah.
Are you sure?
Yes, the drawing one. Yes.
You saw the negative one as well?
Yes, both of them.
Good. Okay. Now, please, Obiambo the seat belts very, very well, because we are now coming to start the applications. In regression, there are 2 main types of regression. We have the simple linear regression and multiple linear regression. When we say we are using a simple linear regression, it means that our estimation technique has only 1 independent variable in it. But when we say we are using multiple linear regression, it means the estimation technique has more than 1 independent variable in it. Please, should I take it again?
Yes, sir. Yes, sir.
Good. Regression analysis can be broken down to 2. Simple linear regression and multiple regression. In simple linear regression, we have only one independent variable in our estimation model. But in multiple regression, we have numerous independent variables in our estimation model. Is it clear now?
Yes, it's very clear.
Good. So I'm building upon it. Now, the regression equation, in other words, the formula we use to do the regression calculation is given by y is equal to alpha plus beta plus, 1 is equal to alpha plus beta x, or y is equal to alpha plus beta x plus error. Now, the y stands for the dependent variable. And that is why I mentioned earlier on that for the purpose of this class, because we are talking about forecasting, the y will stand for the number of people that we will require. So how many people will we need to hire? How many personnel do we need to have in place in order to achieve our objectives? That will be the y. The alpha is the constant or the intercept. The beta here stands for the slope of the linear relationship. So if we try to estimate the relationship between the x and y over here, the beta attached over here will help us to know the strength of the relationship. Then the x is the independent variable, which is also called the predictor. So another name for an independent variable is the predictor or the factors. Now, you see, I have another model over here. Who can tell me the difference between this model and this model? What is the difference? Hello?
Sir.
So we are listening.
Yes. Who can tell me the difference between the first formula and the second formula?
Even the first formula you brought in.
Error.
Hello?
Yes, the difference is error.
Go ahead.
Yes, the difference is the error term. Now, in what you'll be doing in Quanti, they are likely to add this error term into it. And the essence of this error term is that it takes care of all the unforeseen factors you did not take into consideration when you were trying to make the predictions. So for instance, if you did not factor COVID-19 or a possible earthquake, or you did not factor any sort of unforeseen circumstances, then we construe it as part of what? An error term in your model. Please, is that clear? So depending on the question you are given, they are likely to give you an error term, or it is likely to be straightforward. Can you see my screen? The blank one.
Yeah, it's blank.
Good,
yes.
Good. So this is what I've been saying all this while. Regression model is given by this is what we call the estimable equation. Estimable equation. It is called estimable because you are now coming to put the values into it. Okay. Now this is for simple linear regression. Who can tell me why it is for simple linear regression? Hello, who can tell me? Hey. Hello.
Hello, sir.
Yes, Jennifer.
Yes, Jennifer. The variable is 1.
Yes, the independent variable is just 1.
Independent variable.
Thank you very much. Now, if it were to be a multiple regression, which you'll be doing in Quanti, this is how the equation will look like. they will write y is equal to alpha plus beta 1x 1 plus beta 2x 2 plus beta 3x 3. And if they have an error term, they will also add it. But for the purpose of this class, I'm just introducing you to the simple linear regression where we have only one independent variable. Please, is it clear?
Yes, we are clear.
Good. Now, when you write only the equation like this, without putting figures into it, we call it estimable equation. And this estimable equation gives you the opportunity to put in your values, right? The y stands for what?
The dependent variable.
The A stands for what?
The A is constant.
The B stands for?
Slope of the linear.
Very good. And the X stands for? Yes, what does the X stand for? Hello. Hello, can you hear me?
Yes, sir.
We can hear you.
So the X stands for what?
Independent variable.
The independent variable. Very well.
Yes, sir.
So we are building it gradually. Now, in this formula, the B alone, you are seeing here, this B alone, it also has its own formula. This B, it has its own formula. And that is what I'm going to show you pretty much soon. Can you see my screen?
Yes.
Good. So this B that you are seeing here, the formula for it is this. Are you seeing it?
Yes, please.
Good.
B is equal to sigma xy.
Summation xy minus n mean of x multiplied by mean of y all over summation s squared minus n multiplying summation s squared. That is the formula for B. This is its formula. And the formula for A is just changing of subject. It's the same formula that you make A the subject. So you move the A, you move the B, X, and subtract it from Y to get the A. That's exactly what we have here. Please, is it clear up to this point? So you are not in my class. I don't expect you to chew it because if you had even started regression in your class, I would have used SPSS to illustrate, then we'll go. But because you've not done it over there, at least you have to learn it the hard way. Then going forward in future, I will also teach you how to use SPSS to do the analysis. So all you need to know is that the regression equation is given by y is equal to alpha plus beta x. And this beta alone is given by this formula. So let's take a question to understand how you can make the estimation. Please, someone should volunteer and read this question for us.
Examples of regression analysis.
Okay.
As HR planning manager for Damson and Hampson Limited, a dynamic and fast-growing firm located in Takoradi, you have an important task to fulfill. To continue the company's history of successful growth, you need to forecast the number of sales personnel required to achieve 8 billion Ghana cedis and 10 billion Ghana cedis of sales level. You have the following historical data or information available to guide your regression analysis and HR demand forecast.
Okay, please, is it clear?
Yes.
Hello. So who would like to explain what the question is trying to say? Yes, Husseini, would you like to try? I'll say, understanding the question is even part of the solution. So if you don't understand the question, then it will be, so let's try and break it down. What is the question demanding? Let me see. The mathematicians. Genevieve. Genevieve, are you there?
Sir, why?
I heard you are a statistician. That's why.
Who said that?
It's Husseini.
Hey, it's not Husseini. In regard to the question I asked him, that is why he's saying that.
Okay. All right, but can anyone try to break? Can anyone of you try to break the question down?
The question in the statement is to find the number of sales personnel that they will need to achieve the two targets amounts.
Precisely.
8 million and then the 10 million.
Very good. So now, as the HR manager, as the HR manager, they want you to do a forecast and tell them how many people you need to be able to achieve these two different sales targets of 8 million and 10 million.
8 million and 10 million.
Yes.
Sir,
yes.
Be careful with the question.
Why?
He said, as an HR forecast, you need to achieve the difference between 8 million and 10 million.
Debut.
That is what he said.
No. That is not a question. What is it is that they are saying that as HR planning manager, as HR planning manager in Yamson Limited, also the dynamic and this is the dynamic and fast-growing firm located in Takoradi. You have an important task to fulfill. Also continue, to continue the company's history of success growth. You need to forecast a number of sales personnel required to achieve 8 million and 10 million.
Yes.
So the number of sales personnel that you need to employ to achieve the 10 million or the 8 million sales level. Then they have given you the statistics under the this and the context of what is under the this and the diagram.
Yes, for the past 5 years.
You can use that one to calculate. You have to calculate to get the number of personnel you need to achieve that 10 million or 8 million.
Yes. Now pay attention to the table. Sales is in what? Sales is in what?
Millions.
Sales is in millions. Hey, are you watching a different screen?
Yes.
Yes.
Sales is in millions. Yes. And this is the number of people we are trying to forecast. You remember I told you always the number of workers represents what? Hey.
Say, come again.
The number of people we are trying to forecast in the regression model, what does it represent? Okay, so that is the dependent variable. Oh, I was just going to say multiple Bosnia fast because I've taken my time to explain it. Now, so because this is in millions, it means this is what? 2 million, 3.5 million, 4.5 million, 6 million, 7 million. And each of these sales has its corresponding workforce they use to achieve it. So you will have to redraw this table and put 8 and 10 beneath it, so that you do the computation for the 8 and the computation for the 10. Please, is it clear?
So it's clear, but the confusion here is that if they were dependent on only one figure for you to produce, let's say 8 million people, or this 8 million Ghana cedis, how much people will be required to produce 8 million? That one, I think it will be easier for you to, but the two figures that came in the 8 million and 10 million, it's the one confusing me.
It's not confusing at all. So let me tell you something. Listen, so I could have just said the number of sales personnel required to achieve only 8 million. Then the question will end. But this time around, I want you to do the calculation for 8 million. Then you do another calculation for 10 million. Is it clear? So don't worry, we are now building
so it. So they are both in separate calculations?
Yes, they are both in separate calculations.
Okay.
It's not like we'll be using a simultaneous equation or something of that sort. We'll do it step by step, okay? So I'm saying that to be successful, I will say, let's go back to the formula. In the formula, you will see that you will need X, you will need Y, you will need the sum of X times Y, you will need the mean of X, the mean of Y, you also need the sum of square of X, then the mean square of X. So you have to create a different table altogether.
Sir.
Hello.
Please, in the column of the sales and marketing, thank you. The number of workers, is it 20 or 20,000?
Which one? This?
Yes.
It's 20. 20.
It's 20.
Yeah.
Okay, thank you.
But this one is in millions.
Yes.
So usually you have to be guided by the description that comes with each of the tabular sections. Okay. Can you see my screen?
Clear.
Yes, clear.
Good. So I said you quickly create a table, and in the formula, we all saw some of the things we will need, right? So first of all, we've been given what? X and Y. Is that not so? Hello. We are doing it together. So if you don't pay attention, you'll get lost. That will be your end. In the formula, in the B formula, we will need X times Y. We will also need mean of X. We will need mean of Y. And we will need summation of X squared. We also need